Hi everyone. In this video we are going to finish what we started. In the previous videos we saw how the data goes into multiple layers of the transformer decoder. Today we'll look at the linear layer and the softmax. Okay, so in the previous video we had this X output, a tensor of dimension 2 by 4 by 4. I remember 2 is the batch size, 4 is the block size, and this 4 is the embedding dimension. So the last dimension is the embedding dimension, and of course the batch size and all of these dimensions are actually parameters which you can define based on your kind of project or application. Okay, so at the beginning, or say I think it was in the second video, we had this Y, our target, which is something like this: 15, 6 to 30. I think this is 8, 18, 6, 14, 14 and 30. So okay, we'll get back to this. It is very important. But before that, in the linear layer, there's also, just like before, we are going to start with a linear transformation, using X output with W19 transpose. I remember the number of W's and their dimensions determine the number of parameters of the final model. And the dimension of W19 is 4 by 65. Well, this 4 is the embedding dimension and 65 is the size of our vocabulary. Okay, so X output is 2 by 4 by 4. Transpose of this is a tensor of dimension 65 by 4. And when we multiply, we'll end up with a tensor of dimension 2 by 4 by 65. Okay, then after this, we'll apply a softmax function. The output of a softmax is a probability distribution. Okay, now think about it. In here we actually have 8 characters, and each of the 8 characters has a probability distribution of this dimension. And really, this Y is our target. I might not be able to kind of write all the numbers. I think it might be good to scale things down so that it's much more clear and I'm able to explain it. So instead of this dimension, let's say we had a tensor of dimension 1 by 2, let's say by 30, meaning we only have a single batch, and this 2 is the number of characters. We only have 2 characters, and each of the characters has a probability distribution of dimension 30. Okay, and let's see Y is maybe we can see Y is something like this: 0 and 2, which means I'm also going to scale down the vocabulary to be something like this. Vocab, instead of A, B, C, D all the way to the $sign, it's just going to be A, B, C. So it's a smaller vocabulary. The index of A, index of B, and index of C. Okay, this 0 means the target of the first character is A, and 2 here means the target of the second character is C. I think I should write this so that it's much more clear. So, and don't forget there's a probability distribution, which is the output of the softmax. Maybe I can write it to be bigger, so forget about this. Maybe it is something like the 0.09 and 0.2447, 0.6652, 0.0171, 0.9362, 0.0466. Okay, notice that the summation of the numbers in the first row add up to 1. Summation of the numbers in the first row add up to 1. And what this means is, okay, the first column is for index 0 of our vocabulary. Second column is for index 1 of our vocabulary. The last column is for index 2 of our vocabulary. So what this is telling you is, if for example here, you see in here we only have 2 characters. If maybe the first character is A, the second character, let's say, is C, telling me, given A, the probability that the next character is A is actually 0.09. The probability that the next character is B, it is 0.2447. Okay. Probability that the next character is C is 0.6652. The same for this C. So the maximum here for the first character is 0.6652. So based on the model, we're going to take the max. So the model is telling us that the next character is C. For the second character, telling us most probably the next character is 0.9362. And I think I should remind you that really what we are doing is pre-training. So given a character, we are trying to predict the next character. Given a character, we are trying to predict the next character. So, and to remind you also, we're on a character level. On normal applications, where we will not be on character level, we'll be on maybe word level. Given a word, we'll try to predict the next word. Okay. So this is the output of the probability distribution by the softmax, and this is our target. The next thing that we need to do is to compute the loss. To compute the loss, we're going to apply the cross entropy loss. We're going to say log of minus log of. Well, in here we have 0, so we're going to look at index 0, 0.09 plus minus log of. In here we have 2. For the second character, we're going to look at index 2, which is 0.0466. Okay, we have 2 characters, so we're going to take the average, divide by 2. I will end up with 2.73. So this is the loss, and this is what is going to be used for back propagation. I actually made a video regarding back propagation. It will be used for back propagation to update the weights W1, W2, W3. After that, after the back propagation, a new batch of data will be fetched, and the whole process will be repeated. A loss will be gotten, a loss will be calculated, then back propagation, then a new batch. This is how the process is. I think we are done. We are done. We have computed the probabilities, these ones, and you see it's really not something difficult. Notice there are a lot of linear kind of w's being multiplied by, sorry, x being multiplied by different w's. There are a lot of linear layers, and I hope this is very clear. Please let me know in the comments if you have any suggestions, or maybe you have any suggestion, maybe you have any comment in general, or something that you'd like me to change, or maybe there's a mistake. While making these videos, there's a possible I might make a mistake, so let me know that in the comments. And regarding maybe future videos, you want to suggest something that you think is important, a video that you'd like me to make, let me know. I hope you like these videos, and see you in the future videos.